So in this video, I'm just going to show you how to determine if a triangle is right, acute, or obtuse using the Pythagorean theorem. So we know that if it is a right triangle, then always a squared plus b squared is going to equal c squared, where c is the hypotenuse, a and b are any of the legs. So you could have a and b here, or vice versa is fine as well. If we're talking about an acute triangle, notice that if we did consider the right triangle before, it kind of looked more like this, that side is too short to be a right triangle. It's basically like it was going to be a right triangle, but then the side ended up being too short for that. So how that translates in our Pythagorean theorem is that a squared plus b squared is not going to equal c squared because it's not a right triangle, but that c ended up being too short to be a right triangle. So we're going to end up with our c squared being smaller than what it should be. It's going to be less than our a squared plus b squared. With the obtuse triangle, same thing. If we imagine a right triangle superimposed on top of it, we notice that our obtuse angle is bigger than what it should be for a right triangle because it's obtuse. So if I'm looking at my a squared plus b squared, then my c is actually longer than what it would be for a right triangle. So I'm going to end up with my c squared being greater than a squared plus b squared. So for any of our examples, we're just taking the three sides that we've got. We're going to use a squared plus b squared something to c squared and try to figure out if they're equal, then they're going to be a right triangle. If our c squared is less than a squared plus b squared, it's acute. And if our c squared is greater than a squared plus b squared, it's obtuse because it's bigger than what it should be to be a right triangle or smaller than what it should be to be a right triangle. So in these three examples, we're just determining if our side lengths are going to create a triangle that's right, acute, or obtuse. Remember, for any of these, that biggest number is, quote unquote, the hypotenuse, or it could be if it's a right triangle, but we know it's the longest, so if it has any chance of being a right triangle, the longest one will be the hypotenuse. So starting with example 1, I'm going to have my 6 squared plus 11 squared. Remember, we don't know if it's equal to, less than, or greater than, so I like to just keep an open circle or an open box there. You can just leave it blank if you want. And then our 14 squared. So I'm just evaluating either side. I'm not solving for anything. I'm just trying to see how they compare. So on the left side, I'm going to have this 36 plus 121, which is, where'd it go, 157. And then compared to on the right side, my 14 squared is 196. Okay, so when I get done here, I'm just saying, okay, it ended up being greater than, my c was greater than what it should be to be a right triangle. So if my c is longer than what it should be, then that means that that angle ends up being obtuse. So right here we've got an obtuse triangle. For example 2, same thing, my setup, 9 squared plus 12 squared, we don't know, to the longest side, 15 squared. Got our 81 plus 144 is going to be 225. And then on the right side, we are also going to get 225. So if they're equal, I mean, this is the easiest one because we're just confirming, yes, a squared plus b squared does equal c squared, so that means that it is a right triangle. So our last example, we've got 10, 11, and 8. Be careful on this one because they're not in numerical order. So that 11 is actually the largest. I don't think you guys will be tricked by that. Very smart. So set up the same. Our 100 plus 64 is going to be 164. And then compared to 121. And we could kind of notice with this one that the numbers seemed maybe too close to each other. And that might happen if the numbers are smaller, but as they get bigger, those numbers are going to have to be further apart to be a right triangle. So for this one, our hypotenuse is smaller than what it should be. It's less than, and we're just saying, okay, if that angle, that side ends up being less than what it should be, that means that our angle ends up being less than what it should be to be a right triangle. So this is acute.